In the 1950s, Godzilla tore through Tokyo, Japan. Unfortunately, many lives were lost and billions of dollars of property destroyed. So I thought to myself, how could this have been avoided? Today, I'll attempt to show you how an MSE wall could have saved Tokyo from Godzilla. Due to limited resources, an improvised study was conducted. A small-scale wall would be built using the soils provided from the backyard. Then the performance of the wall would be qualitatively assessed under the load of Godzilla before a second identical test would be conducted with paper towels providing tensile reinforcement. When a mound of soil is subjected to a load, stresses will form along a nearly infinite number of potential sliding planes. On each plane, such as the one shown here, both normal stresses and shear stresses will form. In general, soil is ideal for compression, but has limited shear resistance that is a function of both the angle of internal friction, cohesion, and the normal stresses applied. Thus, shear stresses can be problematic to unconfined soil masses where shear stresses from a large applied load such as Godzilla can cause a rupture between two soil masses along a sliding plane, causing the slope to ultimately fail. As the angle between the failure plane and the applied load increases, the frictional resistance from the normal stresses decreases and the shear stresses will increase until ultimately the soil fails and Godzilla will attack your city. For the first test, the miniature Godzilla was sent over a compacted mound of soil and the behavior of the wall was observed. As you can see, the wall was decimated, with a large failure occurring where Godzilla had run over the wall. This not only failed keeping Godzilla out of the city, but it also failed from a structural point of view. This was unsatisfactory behavior, so I had to go back to the Google and find a wall system from some genius guy invented over 50 years ago. Thus, we landed here. A reinforced soil mass, much like a mechanically stabilized earth wall. There are usually horizontal strips of either geosynthetics or steel that provide a tensile capacity in the soil from frictional interface from a normal stress is applied between the two materials. For this test, however, due to budget concerns, paper towels stolen from the janitorial closet would have to suffice. Similar to the first condition, there are normal stresses and shear stresses acting along the numerous potential sliding planes. This configuration, however, includes tensile membranes that resist the soil movement when strained by the soil surrounding it. This way, a confining stress is created which provides a greater shear strength than the soil mass can alone. Thus, we see a soil mass that is much more stable, hopefully enough to finally keep Godzilla out. This second wall performed much better. It was easily noticeable that the soil was much more confined and the wall could handle the heavy Godzilla load thanks to the tensile reinforcement that is now resisting the shear stresses induced from Godzilla. Now, unfortunately, the wall didn't achieve the first goal, which was to keep Godzilla out of the city, but now the people will be tormented for years to come. But the wall did perform so well that there was no reported damage from Godzilla's crossing over, and thus that means that'll be one less thing to repair after he decimates the city.